Hi, in today's lesson, we are going to look at another example on how we convert a block diagram to a signal flow graph. And I'm having this kind of a block here. I have the input, I have this gain block, I have my summing point, I have this block, I'll have the pick off point, I have the block, something like that. So the first thing we need for you to convert the block diagram to signal flow graph, you have to remember all the terms that we've looked at previously about the signal flow graphs. So the first thing you can see, we have from the input R to this summing point, we have this gain block. So I just need to draw a node from this input and another node representing the summing point, so that I'll have something like that is now something like this one, then that one. So that's what I'm having. So this is the same as my input R, then this is my summing point, and of course now in between the two of them I have 1 over S plus A, like that. Then from there, from this summing point to a peak of point M, I'll have this gain block. So from this node to another node here, let me call this one M, I have this one. So I just indicate an arrow, sorry, this one I should indicate an arrow still. So between this summing point and this point M, I have 1 over S. So that is what I'm having from this point to point M, I indicate 1 over S. Indicate 1 over S. Then from point M, from this point M to the output, then I'll have my block K. I'll have block K. So I just have from this point to another point. Of course, this is now my output. I'll have the gain K, like that. And then from there, let us now look at what we have in the feedback path. From there, we have, you can see that from this point M, I'm having this block coming towards this summing point, and from this summing point, I'm having the same block coming towards this summing point. So I don't need to include this summing point here. I don't need to include this summing point. I can just plot this one direct to this one, because we're saying that you can combine summing points. You can combine summing points. Then I just have from point M to where I have my sum. This was my summing point. So I just have something like that. I indicate the direction. So you have to consider this one. This was plus. At this point it is minus. So I just indicate minus. The value here is what? S squared, like that. Then from my output, you can see from this, remember this one, we indicated this one as our output C, because they are meeting with this at this point. All this and this one are meeting here. That's why for signal flow graph, there is no need to have too many nodes. We just indicate the output here. So where I have my output, to where I have this summing point, then I just have my, this is 0.1. So instead of having this summing point here, just combine them here, so that I'll have from this one, from that output to my summing point, the initial summing point, this one, then I'll have my 0.1. And of course, in this summing point, it is positive. When it comes to this summing point, it becomes minus. So I'll have minus 0.1. I'll have minus 0.1. Then, remember we're having this arrow coming towards this output, this node. Then we are having this one, sorry, let me just indicate the direction. Then we're having this one coming away from that node. That means this C cannot be our perfect output. cannot be our perfect output, and therefore I need to create a sync node like this. Then I indicate this one as C prime, and that C prime will be my output. Then we indicate the value of 1 here. If there is no gain block, in that case, we just indicate 1. And that's how we convert block diagrams to signal flow graphs, as easy as that. Thank you so much for watching, and please subscribe to my channel.